Hello and welcome to my first physics lab, constant velocity. For my lab, I recorded the motion of a billiard ball moving at constant velocity across a carpet. The purpose of the lab was to show how Newton's first and second laws could be applied in real life and in a real-life data set. Now, observing these basic parameters of the ball, we see that the constant velocity results in no change in velocity, which means that there's no unbalanced force acting on the ball based on Newton's first law. We also see this applied in Newton's second law, which shows that because there's no change in velocity, there's no acceleration, which means there's no force acting on the ball. I used the tracker software to determine the experimental data I later plugged into the Excel graph sheet. Now here you can see my tracker, the pool ball in tracker, and you see a calibration stick in blue and you see the axes in purple. Now these axes were used to determine the ball's relative movement across the x and y axis given. Now, I said that the ball was moving across the x-axis based on the way I positioned my axes, which are purple. If I had flipped the axes, the ball would have moved up or down along the y-axis, and this would have resulted in a situation where the velocity magnitude would have been the same, but its direction would have been in the y direction rather than the x. In this screenshot, you can see the output graph and data in tracker. Based on the tracker data, I determined initial velocity, initial position, as well as initial time. These initials were later used to be plugged into the computer model in VPython. I used these kinematics equations in the Python program as shown to determine the movement of the ball, theoretically. The Python also gave me an output list of numbers, which then allowed me to compare my model to my experimental as plotted in Excel. Because I used the same time step in VPython as was used in Tracker for the experimental position, I could compare both the data sets and plot them against the time on the same graph. Unfortunately, there's a distinct deviation between the red, the model, and blue, the experimental data. Now we have to ask the question, why does this deviation occur? If you look at the graph, you see that the red model has a constant negative slope while the blue experimental kind of tapers off. We see that the ball slows down rather than following the path of the model as it should. Now, why could this be? We realized that our initial assumption was incorrect. The ball is not moving at constant velocity. Therefore, there must be a force acting on the ball. Now we can ask, what force is this? This force is the friction of the carpet rubbing against the ball and slowing it down. Here we can see the application Newton second. In my lab, you can see that both the first and second law of Newton's are visible in the model and experimental data collected through Tracker and the computational model. You can see how Newton's laws can be applied in real life.